Welcome to this introduction to Micronaut and GraalVM. For those of you who don't know who I am, my name is Graham Roche. I'm the creator of a couple of pretty well-known frameworks in the Java space, Rails and Micronaut. I'm an architect at Oracle Labs. I received an Oracle Groundbreaker Award a few years back for my contributions to open source. And I'm currently leading Oracle's contributions to Micronaut. Do connect with me on social and those two links. On the agenda for today, we're going to look at the background that led to Micronaut. We will do an introduction to Micronaut and an introduction to GraalVM, and we'll talk about how much they work beautifully together, and we'll do a whole bunch of demos. So in terms of what led to Micronaut, if you look at traditional architecture in the Java space versus modern architecture, in this diagram with traditional architecture being on the left-hand side here, in the past, what typically happened is you would deploy your Java apps to a single Java virtual machine, running a container, typically Java EE or Tomcat or something in that description. And each app would be deployed within that Java virtual machine as a WAR file or some such packaging format, maybe an EAR. And that gave the JVM a fair amount of ability to essentially share memory across those apps and optimize things and so forth. Switching over to how applications are being deployed going forward in the future and in the cloud, you have this. This diagram hopefully illustrates that. You have your containerized deployment model, where essentially each application is running inside a container orchestrated by Kubernetes and so forth. And this is your typical cloud architecture nowadays. And traditional frameworks such as Spring CI and so forth make extensive user techniques that are not great in terms of memory consumption and startup performance in the cloud. Things like reflection, runtime bytecode generation, runtime generate proxies, dynamic class loading, and so forth. These techniques typically have an impact on startup time, memory consumption, and so forth. And in a microservices environment or in a serverless environment, for example, where you have multiple JVMs and you don't have the opportunity to share memory in between the different JVMs, frameworks based on reflection and annotations can become very fat. Although people really love the programming model, so they tend to stick with it. Now, this long-term is going to become more problematic over time as cloud billing models come into play, as people start to think about how much memory is my container occupying, how fast does it start up for serverless, what is my cloud services bill, and of course you can turn many of these features off, these productivity features of these frameworks. But the drop-off in productivity is massive. And we found when we started looking into Micronaut that there was this relationship in typical Java applications based on this model, where as your lines of code increases, so does your startup time and memory consumption. And this is what we wanted to address with Micronaut. In addition to that, if you look at Java's problems for framework developers of any framework, there are various issues that every framework developer will have to face in terms of the annotation API in Java being tied to reflection, being quite limited in that it doesn't compute automatically for you inherited annotations from interfaces or meta annotations and so forth. Generics was added after the fact to Java. So having to deal with things like type erasure, and there's massive amounts of code in typical frameworks to resolve, is this thing a list of string? Which, yeah, it's a list of string. I can see it in my source code, but then at runtime, how do you deal with that? Reflection as well has also been a thing that has been tried to be addressed over and over again in the framework space with different solutions such as CGlib or ByteBuddy or Java Assist, trying to optimize reflective method calls, which are typically slower than your regular method calls. And the other problem is the proliferation of reflective data caches. So if you think about it, for example, your typical Java stack might have some Spring in it, might have some Jackson in it for JSON marshalling, might have some Hibernate, and each of those libraries have their own reflective cache for reflective data, like java.lang.reflect method. The reason for this is because it's expensive to retrieve reflective data. So it tends to be retrieved and then cached. And there's no like shared cache for all these different libraries, so each one tends to be its own. And since these java.lang.reflect methods are typically held in soft references, by the Java virtual machine, they end up never being garbage collected. Another common technique in terms of starting up applications is class path scanning. In terms of discovering components. So different components that are, for example, annotated with @singleton or @controller. Somehow you have to discover those at runtime, and a typical technique to do this is to kind of do bytecode scanning at runtime, which is really, really bad for performance. And the other issue that we tend to see is dynamic class loading, where a container, a Java container, for example, you may have extremely deep class loader hierarchies that can impact performance and make applications much harder to debug than necessary. In terms of why actually reflection is a problem, and it's actually pretty easy to understand. Today, the JDK is OpenJDK, and you can go to the source code and look at it on GitHub. And if you look at the source code for java.lang.class, you'll find that reflective data is initialized on first access, and all reflective data for a class is initialized the first time you access it. So that means every field, every constructor, every method, and it's stored in what's called a soft reference. So a soft reference is essentially a reference in the Java virtual machine that is not garbage collected until the virtual machine is low on memory. So you can see that initializing all this data is expensive to load and then expensive to keep because it occupies memory. Now, how much memory? In our measurements, what we've done so far, a typical java.lang.reflect method would occupy maybe 100 bytes of memory. But in a large application, there could be thousands and thousands of methods in your application, which can lead to, I've seen examples of hundreds of megabytes of memory being occupied just by reflective data caches. So with that in mind, that was the background that led to Micronaut. And in terms of what Micronaut is, it's a microservice and serverless focused framework, hence the branding. It's also a complete application framework of any type. So what that means is you could use it to build anything, right? Anything that has a static void main, you can use with Micronaut. We have folks using Micronaut to build command line apps, to build UI apps using JavaFX and Swing, and of course microservices and serverless, which is very, very common. It's also a Java annotation processor, so it hooks into the Java compiler and essentially computes your framework infrastructure at compilation time. And Micronaut is essentially the result of lessons learned building Spring and Grails over a 10-year period and not wanting to repeat those same mistakes at the framework design level. So we like to talk about Micronaut as essentially build time framework infrastructure. And what it does is at compilation time, it will compute all your dependency and configuration injection. All annotation metadata is computed at compilation time such that you never need to actually use reflection to access annotation metadata. All AOP proxies, bean introspections so that you can instantiate and find out what properties a bean has without using Java's default java.beans.introspector, which relies on reflection. And pretty much everything in Micronaut is reflection, runtime proxy, and dynamic class loader free. So with Micronaut, you can build microservices, serverless applications, message-driven applications with Kafka, CLI applications, even Android apps, anything static void main, and it supports Java, Kotlin, and Ruby. In terms of Micronaut's impact, Micronaut was launched in March 2018, and it was open sourced in May 2018, and it sparked industry-wide improvements across the industry, from improvements in things like Spring Boot to improvements from companies like Red Hat with Quarkus. And it's literally changing users' expectations from framework frameworks in the Java space, and it's even impacting some folk that maybe are a little bit closer to home in the Microsoft world, with David Fowler, creator of .NET 4 at Microsoft, saying that some of the principles behind Micronaut is what they strive for in ASP.NET. There's a little quote for you. So in terms of GraalVM, GraalVM is a new virtual machine out of Oracle Labs that increases your application throughput by up to 20 to 30% in JIT mode. But it also allows you to compute Java applications into self-contained native binaries, which is great for cloud deployments because it dramatically reduces memory. It also includes a truffle language framework that allows you to seamlessly integrate different languages and so forth. So you can, for example, invoke JavaScript from Java and vice versa, as well as other languages like Ruby and Python and so forth. And Micronaut is really great in combination with GraalVM because it's essentially a match made in heaven in terms of computing native images, because in order to compute a native image, it needs to analyze what's known as a closed-world static analysis. And because Micronaut doesn't do any reflection or have any runtime proxies or do any bytecode generation runtime or have any dynamic class loading, there's literally nothing to configure for GraalVM. It's really, you can literally feed GraalVM a Micronaut application, and it will produce a native image automatically because there's nothing you to do extra. So they are a great combination together. And the way to get started with Micronaut is to go to Micronaut launch. If you go to launch.micronaut.io, you can generate and create a Micronaut app, which is then accessible, which you can import into your favorite IDE. It's also a completely, Micronaut launch is also a completely serverless backend powered Micronaut application. So it's written in Micronaut itself, computed into a native image, and running serverless. So the source code on GitHub is a great example of using Micronaut to build a completely serverless application. So with that, a lot of talk. Now I'm going to do some demo. I'm a CLI guy, and one of the things that Micronaut also has is a command line interface, which you can install via SDKman, which I'm going to use. So I'm going to do mn create app and cd into it, and then I'm going to open that up inside of an IDE. And we're going to go into presentation mode. And this is your Micronaut application. So you have an application class, which is your entry point, which you can run directly from your IDE. So I can right-click and run this application. We also have a test here. Want to directly run this from your application and start testing your app straight away. And you can see that one of the things with Micronaut that we wanted to achieve was extremely fast test execution speed. So this is a full integration test that loads up the application inside, embedded in the test, and you can see when I run it, it executes really, really fast. So in terms of what you can do with Micronaut, what you can do is I can create, for example, a person class like so, and I can annotate it with retrospective, which tells Micronaut that it should be available for bean introspection, and I can do things like define a name like so, and an age like so. Make that final as well. There we go. And create a constructor, create some getters, and there we have like a Pojo that we can use in our demo application. I can then create a person controller like so, and with a controller we can map it to a particular endpoint like people, for example, and maybe we have a get action that maps the root URI and lists all of the people like so, and import that. You don't want the java.auth one, that's for sure. And maybe we have a person service, for example, that maybe provides my people. Again, this could be something that you at some point, back onto a database or something like that. And we can list all the people here like that. And at the moment, we're just going to do return as list, new person, Fred, 30, new person, Bob, 10, or something like that. So we can then use dependency injection to get a hold of that. So I can use constructor injection to automatically inject the person service like so into my controller, and I can create a person service, and then I can use my person service to list all the people, and there we have a controller. So how would I write a test for this? I'm going to write a person controller test in my test, and this is going to be a Micronaut test like so, and it's going to be a JDConf test, which I'm going to test the list people. And what you can do is you can write an interface that's going to be my client, and it's going to invoke my people endpoint like so, and we can even use the same more or less signature in the client like so, and inject that person client like that, and then we can say assert equal to client.list.size, and we can run that, and hopefully if all goes according to plan, it should pass. So there we go, my test passing. Now this is a full integration test, so you can see that if I were to come into my login configuration and add login name equals io.micronaut.http.client, level equals trace, you'll see that, and I'll run it again, you'll see that the output of the request is going back and forth. And you can see the JSON in there, coming back from the server. So what is Micronaut actually doing here? If you look at the build directory and my classes directory, you can see that in addition to my regular classes, my application, Micronaut is using pre-computing a bunch of internal synthetic static classes which contain your framework infrastructure code for you. So so at runtime, it actually doesn't have to do anything; it just has to load them, and everything stays super fast. Now, once you want to go native, what you can do is open up a terminal window, and you can say GraalVM native image, and this will take my application and it will build a native image from my application using GraalVM native image. So it's got GraalVM native image uses, like I said, closed-wall static analysis to compute the native image. So this process is relatively heavyweight in this will take some time, but by the end of it, I will have a native image which I can which will consume significantly less memory and start up significantly faster than your regular application. So in order to stay within time, I'm going to switch over, and we'll pop back to see when the native image finishes. But essentially, in terms of Micronaut itself, the project is healthy. It's has many different contributors from across the industry, with engineers from Object Computing, Oracle, and Google working on the project. 4.2K stars and over 9.3K commits. The source code repository is there. Do star us and show us your support. We would love to hear from you, and if you try Micronaut, there's a discussion forum, and there's a GitHub channel as well. In terms of Micronaut and Azure, Micronaut works great with Azure, and you can deploy Micronaut apps to Azure in a number of different ways, typically containerized to AKS. And there is a Micronaut Azure project as well that allows you to deploy Micronaut applications to Azure function. We also have a guide on how you can deploy your Micronaut app to Azure Cloud, which you can find at that link down there below. So in summary, And before I go to the summary, I'm going to swap back here to my native image build. As you can see, it completed in just 1 minute and 22 seconds, so it took a little bit of time. And what I can do is I can go build native image and run my application directly, and you can see that when I run it, the application actually starts up in just 22 milliseconds. Which, if you compare that to the Java version, which I can do, I can package up the Java version, the raw Java version, and package it up into a Google, and I run the Java version like so. You'll see that the Java version starts up in 728 milliseconds, with taking, not slow by any means, because Micronaut is pretty fast to start up by Java standards, but certainly not 22 milliseconds, which is phenomenal in terms of cold start performance for things like serverless when you need your application to start up immediately. So in summary, Micronaut and GraalVM are leading the AOT revolution. Server-side Java is adapting to the serverless world, and things like Knative and all the serverless platforms. Building more efficient applications is possible right now, the right framework choices. By using AOT, you can see you sacrifice compilation speed, but you gain significantly more ridiculously fast data time on GraalVM native. And native Java applications is now a real possibility in the Java space with GraalVM native image. In terms of Micronaut resources and things you can find out more, we have a Git community. Use guides at that link there. You can create applications at launch.micronaut.io. We have a whole bunch of guides at guides.micronaut.io, and you can follow the Twitter account and do check out the source code on GitHub. Thank you very much. And if anybody has any questions or Bruno or anything like that, do let me know.
This is great, man. Appreciate you sharing Micronaut. It's one of the frameworks that I tried, I think, a couple of years ago when Micronaut got started. One day I thought, okay, what are these years framework in the Java space? So the usual stuff, Spring, and then Drop Wizard, and Spark Java is also something interesting. And then I'm like, what is this Micronaut thing? And then I checked it out, and I liked it. I liked it very much. So it's very clean, very easy to work with. So great job, you and other folks who contribute to it. It's an amazing piece of technology, and it's surviving the cycle of new framework every year, and Micronaut is still there and growing. That's very powerful.
Well, yeah, I think that I think with Micronaut, if there were other technologies that were not copying it or using the same approach, we would be worried, because then you actually haven't got something that is that cool. But because there's so many other technologies that are essentially, replicating the Micronaut approach or going the same way, it's justification for how it's been built. I think it's having a big impact on the market.
Yeah, exactly. And I think the plug with GraalVM works very nicely as well, because at the end, there are some use cases, some scenarios where you really want that small footprint, where you really want that startup time. And if developers can trade off the compilation time with that for production and scalability needs, that works great. But the way how Micronaut works on both ways, JVM and GraalVM, it's just amazing. And I think that's the feature of the Java frameworks. They will have to work with both.
Yeah, absolutely. I think, and at some point, I think GraalVM, building native images should become a service that you consume in your kind of build CI/CD pipeline. And our target with Micronaut is to have everything that works in the Java mode to work in native image mode seamlessly. And yeah, the compile times are longer, but you see you get a lot of benefit in terms of your production characteristics. And I did manage to build a native image within the scope of a 25-minute talk. So there you go. I think
I'm loving these 25-minute slots for virtual conferences, because then speakers have to go and boom, this is it, boom, boom,
boom.
It's
like boom, boom. I had to switch back to carry on presenting while the native image is building. So yeah.
Exactly. One last question before we bring next speaker to have a chat. when can we see, or have you observing any interest on Micronaut extensions for Visual Studio Code?
So I will just say, watch this space. I won't say anything more.
Sneak peek. All right, awesome. That's
I
very
can't
glad to
give you a
hear.
sneak peek, but watch the space, and yeah, you will see some things in the near future.
Sweet. Nothing here. Nothing happened. Just usual chat.